Hello, everyone. It's been a while since I spoke at the Philly Jug. A big part of that is because I have been working with Python a lot over the past few years. But I have kind of kept myself in the Java space. One of the things that I do is I maintain an open source library that contains logging appenders so that you can have your application logging going to different destinations in AWS. And when the Log4Shell vulnerability got announced in early December, I had to go and make sure that my library wasn't vulnerable and also update the examples to use the non-vulnerable version of Log4j. And I'm guessing that at least some of you spent those few days really scrambling to update all of your applications and redeploy them. And you certainly have my sympathy. So I'm going to start, for those people who aren't familiar with Log4Shell, or dive in maybe if you haven't really dug into it. And like a lot of things that cause big problems, it was an unanticipated collision of relatively innocuous features. And the first of these is the idea of lookups. And Log4j2 has a way to get access to things outside of your application, such as here, your host name coming out of the environment. I'm going to sidetrack for just a minute here and point out that this vulnerability only affected Log4j version 2. And the backstory of Log4j, it's been around for 20-something years. It was turned over to the Apache Foundation sometime around 2010, 2009, can't remember. The original maintainer then had a bit of a falling out over direction of the project with the other maintainers at Apache. He went off and created Logback, while the Apache developers decided that they couldn't really extend the existing code base. So like you do, they forked and started from scratch. So you've basically got three main logging frameworks in use. Log4j1, which still used in a lot of places, Log4j2, which has this vulnerability, and Logback. So I just wanted to give that background. The idea of a lookup, if you read the documentation for it, it says you can use this in configuration to get access to information in your system. And for configuration, it's just a fabulous thing. In fact, my logging library has its own version to get things like the EC2 host that you're running on. So all well and good. This is an unabated good feature, in my opinion. One of those sources you could get data from is Jindy, the Java naming and directory interface. And like I said, I haven't been deep into Java for the past few years, but certainly around the early 2010s, Jindy was how you configured your enterprise app. And not only could you get configuration information out of it, but you could also, Jindy internally was set up so that you could, for example, just ask for a data source and you'd configure whatever your Jindy provider was with the information for the data source. Jindy would actually instantiate it and give it back to you. This is, again, I think an unmitigated good thing, at least for the time when Jindy was the main way to configure your apps. But Jindy had a hidden secret. Not only could it instantiate new objects for you, it could also go out to your Jindy server and get the class files that go with them, load and code remotely. And we look at this today and say, what were they thinking? But it's important to remember that Java originated as the runtime for a set-top box. When it started to become popular in the mid-90s, the internet wasn't what it is today. And the expectation is you're going to be running these Java applets inside your LAN. Sun's slogan at the time was, "The network is the computer." So you'd be amongst friends, and yeah, it makes perfect sense. In fact, if you look at the Jindy docs, you'll see that they give an example of why you'd use this, and they talk about you might want to print something, but you don't have the printer driver for your particular printer. So that's okay, Jindy can load it for you. Today, this is probably not a good thing. After the vulnerability, the various extant Java runtimes have been patched so that this isn't enabled by default. But I suspect that it was created 25 years ago and nobody thought about it since. So this is the first thing that's a little bit questionable. The second thing that in my mind is a little bit questionable is that Log4j2, and after this I'm just going to call it Log4j, would use its lookups in the messages that it logged. So that if you logged a message uh, with somewhere inside of it a $brace env :hostname, it would go out and replace it with that environment variable. Now, I'm going to take another side trip here, and pattern layout is a layout manager, and logging frameworks, the big three at least, have three components to them. One is the logger, which is what your program interacts with. You instantiate it or get it from a factory and say things like logger.debug and pass it some string or whatnot to log. The other side is the appender, and the appender is what talks to some destination. It could be a file or the console or AWS CloudWatch. And in between those two, you have a layout manager. And the logger collects a lot of information into what's called a logging event. And that includes not only the message you log, but the timestamp, potentially the location in the code, a whole bunch of stuff, the thread. And then you use the layout to actually format, and the appender writes it to the output. So there are a number of different layouts. One of them, which was not vulnerable, is JSON layout, which writes JSON objects, stringified JSON objects. But pattern layout is probably the most commonly used layout manager. It lets you construct human readable layouts. So this is something that I think very few people knew existed. I've read the code of pattern layout, and it didn't hit me that it was doing this. And it's been in Log4j2 basically since the first release and edited over time as the code naturally grew with subsequent releases. So this is an intentional thing, a good idea or not. And then the last piece of the puzzle is that developers log unsanitized data. And I throw this in primarily because I read someone who was proclaiming, what idiot doesn't sanitize their data before you log? And the answer is, well, I don't. I don't expect to have to. And in fact, I wouldn't know what to do to sanitize it. Should I get rid of any $braces? How about double braces? You could have your application code containing a whole long list of sanitization steps. But where the real problem of sanitization and logging unsanitized data kind of leads me to the target, which is web applications, public-facing web applications. If you're just writing some back-end code that takes data that you're very certain you know what it is, does something and logs what it's doing with that data, again, you weren't vulnerable. Where you were vulnerable was if you had a public-facing web app, because some web app frameworks would do the logging for you. Tomcat actually wouldn't. Tomcat had its own library for creating access logs, but other frameworks would write an access log without sanitization. And if you had a $brace in it, it would start doing substitutions in that access log. And this is pretty scary. And if you think about Jindy being able to load remote code, it's extremely scary. But I have something that's more scary than that. I don't think remote code execution is what you should be concerned about. So this is an example URL attempting to exploit the vulnerability in the wild. And this comes from a Cloudflare blog, and they were really on top of this. Cloudflare, if you're not familiar, is a company that provides content delivery network and related functionality. They have a web application firewall that can block requests like this, and they were updating it and watching the requests that come in. And in their blog, they're talking more about the extent that people would go to try and hide what they're doing. So, if you look at this first line, if you can read it on your screen, they're trying to retrieve the foo environment variable, which most people won't have set. And if it's not set, they replace it with a J, which then gets concatenated with NDI, a lowercase l, starting out as an uppercase L. So it turns it into an Jindy :LDAP URL, going out to some host somewhere. So yeah, this could be remote code execution, but if you look down at the end of this, you're going to see some passwords in it. And what this really is all about is data exfiltration. Uh, all that this attacker cared about is that they were going to get, for their app server or their Jindy server, an access log that started to contain people's passwords, assuming that they were specified in the environment. And once you have once you have a password, once you have the host name where it's running, you can start to really try and do some damage, and get the information quickly, and then uh, really exploit the vulnerability at your leisure. So with all this in mind, I want to talk about a few of the features that cloud services in general and AWS in particular uh, give you that would let you mitigate this vulnerability. And I'm going to focus on AWS simply because it's what I've been using for the last 14 years. But before I start, I am going to pause and see if there are any questions. And there's an ask a question at the bottom of the screen if you want to put in your question. Okay, I'll move on. Feel free to ask questions as we go. So what I'm going to talk about is first networking and deployment. And kind of the first task that you should do is guard the entrances and prevent exploitable or exploit requests from coming in. I'm going to start by having what I call the lift and shift web app. And this is a case where you're running a web app in your own data center, you want to move it to the cloud. And in Amazon's case, they provide you what's called the virtual private cloud, which is a software-defined network, along with the ability to run virtual machines, other compute databases, a whole lot of features that basically isolates you from other users. So if you're just doing lift and shift, you create your AWS account, give them your credit card, and you'll find that you have a virtual private cloud in every region. AWS has, I think, something like 20 different regions around the world where they operate. And inside that virtual private cloud, you'll see what are called subnets, basically chunks of address space where you deploy something. And with the default VPCs, all of them are public. And what a public subnet means is that anything running in it can have access to the internet. Doesn't have to. You don't have to give it a public IP, but you have the opportunity. Well, if you're deploying your Tomcat server, you're going to give it a public IP. There is one more feature, the security group, the red dashed line here. And a security group is like a per host firewall where you can say only open up certain ports to certain addresses. So for example, in your Tomcat server, you could say open up ports 80 and 443 to the world, but nothing else. In your database security group, you could say open up port 5432 to just addresses within my VPC. And you can actually get quite a bit of, quite clever with your configuration. So this is about as safe as running in your data center. Probably more safe because unless you really mess up the security groups, simply because the security groups are better than perimeter firewalls. But it has some issues. Number one, since you're going to give your Tomcat server a public IP, it means that it can talk out to the internet as well as getting information from the internet. And you have the issue where Tomcat's a very mature technology, but if it had some sort of a vulnerability with a crafted request, let's say a request that's exactly 372 bytes long causes it to fail for whatever reason, you're exposed to that vulnerability. So if you're doing a cloud deployment, the standard cloud deployment looks like this. There are actually a few more components, but the key point is now, in addition to your public subnet, you have a private subnet. And the private subnet, you have no ability to contact the outside world. So your Tomcat server is running in there. It gets a packet that has Log4J escapes in it. It tries to contact a Jindy server, and that attempt just times out. But you still need to expose it to the internet somehow. So in front, in your public subnet, you have what's called a load balancer. And the idea of a load balancer is a very useful thing. Is it accepts requests. Typically, you'll terminate SSL at the load balancer and then pass the request on to your app server. And you can spin up multiple app servers to scale horizontally. Your load balancer will round robin them. And from my perspective, it has one more very useful attribute, and that it's a managed service. AWS is responsible for this thing running. So if something fails with it, you're not the person waking up in the middle of the night to fix it. There's a team that's probably already awake. They will swarm it. They will fix it. They will get the fixes rolled out probably before anyone notices. So my big thing about the cloud in general is the idea of managed services, that they really do make my life as a developer much easier. Okay, so we're pretty good. We're not going to be sending any bad packets out, but we still might get them in. And that brings in the last component of the story, which is a web application firewall. And I had mentioned it in passing a little bit earlier. And the idea of the web application firewall is it's not simply blocking ports and addresses. It's applying rules and paying attention to the requests. So a typical thing, a typical rule might be saying, if I get more than 100 requests to my login endpoint in a minute from one IP address, don't let that IP address make any more requests to my system for an hour. So it prevents brute force attacks. Balance with that. You might have a lot of requests coming because it's from a corporate network. The other rule could be look at the URL, look at the headers. If you see a dollar brace anywhere in those, reject them. And again, as I said, Cloudflare, the company, I think, did a better job at this than AWS. You basically have to pick rules or construct them yourself for AWS. Cloudflare has a set of default rules that when this exploit was happening, they updated their default rules to protect against it and applied those default rules to all their clients. Again, a benefit of managed services, in this case, Cloudflare. So this is all well and good. We are blocking our requests, except for one small problem. And that is real-world apps can't just be locked away in a private subnet. They need to talk to the outside world. On the one hand, you might be going to a third-party service, something like Twilio SendGrid, to be sending out your emails. Or you might be going to Amazon services, such as S3, SQS, or the simple email service. And something that I often stress when I'm talking about Amazon Web Services is that the important part is web services. Everything that you do in AWS starts with a get, put, or post to a public IP address. Sometimes that's obvious, such as when you're uploading a file to S3, it's a put. But even when you're starting up a virtual machine, you're basically put, I think, or post, doesn't matter, to an endpoint on the public internet. So if you lock your app server into a private subnet and it needs access to Amazon Web Services or third-party servers, you've got a problem. The kind of standard solution to this problem is a NAT, or Network Address Translation Device. And the idea is that the NAT sits in your public subnet, you have your app server sitting in your private subnet, and you have routing rules that say every time the app server tries to contact anything in the outside world, route it through the NAT. And this is pretty safe. You can't have things coming back in. It's not like exposing your app server in the public subnet to the entire internet. The NAT is only passing on requests that the app server makes. But unfortunately, the NAT is not selective with who it lets you talk to. You could talk to a good third-party server. You could talk to an evil third-party server. The NAT has no way to differentiate. So there are a couple of ways to start protecting your servers in this world. The first one is the security group, which I described as a per-host firewall, lets you set rules for traffic going out. So for example, I had mentioned earlier that the security group would allow ports 80 and 443 to come in, you could say, let traffic go out on port 443 to this particular host. And if you don't mention the host, then the traffic gets blocked by the security group. You can't make the connection. And this was pretty sufficient 10 years ago. But the trouble is, a lot of services on the internet now have multiple IP addresses. Uh, you know, if you do a naming lookup for Google or for any of the AWS endpoints, the IP addresses that you'll get today are not going to be the same as the addresses you'll get tomorrow, which makes trying to control access to those through your security groups completely infeasible. So one alternative, if all you need to talk to is AWS, you can use what are called VPC endpoints. And VPC endpoints basically have a one-to-one correspondence with AWS services. So, and work by basically changing the DNS lookups for those services to point to the endpoint. So if you need to post a message on SQS, you have to have an endpoint for SQS. If you're uploading or downloading files from S3, you need an endpoint for S3. If all you do is AWS and you have a small number of services, this isn't too onerous. But if you have a lot of services and you're running multi-region, your management overhead to do this is going to be more pain than you might want. Although it is cheaper to move traffic over an endpoint versus a VPC, so you might decide to pay that pain simply because the amount of data you're moving is large enough. Excuse me for a moment. Another alternative is to use an internet proxy. And you may be familiar with reverse proxies, where you have the proxy sitting in front of multiple hosts so that they all appear to be on the same IP address. This is kind of the reverse. The client, or the thing that's making a connection, knows that it's going to a specific host name, but says, route this by way of the internet proxy. And a lot of corporate networks have transparent proxies set up so that all your web requests go through the proxy. And that can be useful to, if you're working for Lotus, you might want to block all access to Microsoft. True story from the 1990s. So the proxy lets you set this up. You can't do transparent proxies in a VPC, at least without getting into IP tables, which is probably getting far deeper than you want to do. You don't want to replicate your data center running in Amazon. But you can give your proxy an allow list, and it says, okay, I can go to all of these Amazon services. I can go to the good host. I won't go to the bad host. I just won't forward the request. And you can specify for the proxy as a host name. So it's pretty easy to configure. This shows the icon for the squid proxy. Once you've understand the docs, it takes 15 minutes to bring up a squid proxy. Very easy to set up. Not so easy to use, because your application code has to tell whatever's making a connection to use the proxy. And I'm certainly not going to go through this code, but let's just say that if you didn't have the proxy, you'd have one line to connect to create an S3 client. With the proxy, you have to have all this additional code for every connection you make, every AWS client, every third-party connection. So proxies can be useful in some small cases. It's probably the lowest cost alternative for the general case, but it's probably not something you want to do. What I think you want to do, what I believe you want to do, is to put in a network firewall. And I had talked about how the web application firewall applied rules to messages coming in. The network firewall basically does the same things to connections going out. So you keep your NAT. Your app server doesn't need to know that there's anything between it and the outside world. It routes all requests through the NAT. The NAT then goes through the firewall. But the firewall applies some rules, such as you're allowed to get to the good host, you're not allowed to go to the bad host. It's basically, it doesn't mention the bad host. So you get the protection so that even if you do have a vulnerability, you're not going to exfiltrate code with that vulnerability. The downside of the network firewall is that your deployment becomes a little bit more complex. You have to start changing your routing rules and the cost. And I don't know how many of you have heard of a guy named Corey Quinn. He works for a company that reduces your AWS bill, provided you're paying more than $100,000 a month. And he tweets incessantly about how horrible NATs are because they charge you for traffic. Well, I think the reason he tweets so much about NATs is simply that he doesn't know about network firewalls, because they basically charge you for traffic, but 50% more than NATs. So this is what I think a proper deployment if you want to protect yourself from remote code execution and data exfiltration. But that's not everything that the cloud can do for you, and it's I don't think enough to truly protect your apps. So before we move on to the next section, I'm going to see if there are any questions here. It looks like there are no questions showing up on my screen. Hopefully that's not simply Crowdcast. Let's move on. So you've got your networking configured to protect yourself from bad requests coming in, protect yourself from data exfiltration and requests out for remote code execution, but you could still be vulnerable. And we've seen the rise, especially in the last several months, of protestware, where open source software that people depend on uh, either gets taken down, so it's no longer available, or has code inserted into it that could be malicious. There's one piece of software that's gotten a little bit of notoriety recently from deleting all your files if it's run on an IP address that is within the control of Russia. So if you're deploying an application, you want to control the blast radius of any problems. Confine the vulnerability to one application, preferably to one small part of your application, which you can then address independently of the rest of it. And this is really where cloud deployments excel. And I'm going to be speaking very much in terms of AWS for the next few slides. All of the cloud providers will give you similar capabilities for your network. I'm pretty sure the major cloud providers will give you equivalents to what I'm talking about, but as I said earlier, this is what I know. So the first thing is application roles and permissions policies. And as I said, Amazon Web Service is a web service. When you upload a request, you are calling out to a certain endpoint on the internet, and you're providing a user identifier, an access key, and you're signing certain key parts of that request with a secret identifier that never goes out. And when Amazon gets your request, it says, okay, this is the user, validate that they properly used their secret to sign the request, and then say, what are the permissions that this user has access to? And a user in this case, really, they use the term identity, could be an actual physical user, a person doing something, or it could be an application that's assumed a role to do its activities. So here's an example application role that says allow uploading objects, the S3 put objects, to one S3 bucket. Nothing else. You can upload, you can't download, you can't look, you can't see what's on the bucket, you can't do anything except for this. So if you have a microservice environment and you have some component of your environment that's responsible for handling uploads, it can have this application role and just be able to do uploads. And the way application roles work is it also has a limited time frame. Basically, the credentials are generated as needed and are only valid for typically 15 minutes. So even if somehow the credentials do get leaked, they can't be used for much. But the key is having really granular permissions. Several years ago, Capital One had an exploit where data that they had stored on S3 in private buckets, what they thought were private buckets, was leaked to the world. And what happened is that one of their applications was exploited, and it had a very wide-ranging permission policy. So the person who was exploiting was able to use that one vulnerability and expand out their reach. So if you're doing a deployment on AWS, one of the first things to understand is the permissions model. And as a hint, do not use the predefined policies that AWS provides. They're way too overpowered. I really wish they'd get rid of them. Okay, so roles are good. Roles control your permission. Accounts put an even more solid boundary around your permissions. And accounts let you give applications and users different permissions. So for example, your developers may have full admin rights in your sandbox account, but only have read-only to see what servers are running in your production account. And there's a lot of configuration you can do with this, so that, for example, you can have developers assuming limited duration role to get into different accounts. And you can really lock down your actual long-lived user privileges. There Back 10 or so years ago, there was a habit of having one account and dividing out between multiple VPCs or virtual private clouds. But really, it costs nothing more to have many accounts. And although there is a somewhat larger management overhead to keep track of who has permissions and what, it gives you a very solid wall between what users can do. It also gives you another feature called a service control policy. And this is an example of the policy that we use on an extract of the policy that we use on our sandbox accounts at Chariot. And it basically says deny every action on every resource anywhere outside of the 4 US regions. And so, if someone were to leak credentials, if you are going to exploit a credential leak, you're going to do whatever your bad thing you want to do somewhere where nobody's going to notice it. So if you're working in, let's say, US East 2, you're going to be paying attention to it. You're going to be in the console every day. You're going to see if something unusual happens. You probably won't be looking at Frankfurt or I can't remember the name of the Australian region. So people who are going to do an exploit are going to try and do that, are going to try and run their Bitcoin mines or whatever in those regions that you're not actively using. And you don't discover that until you have a really big bill at the end of the month. So the service control policy gives you a way to lock that down and simply say, no, we're not working and doing anything in Frankfurt or in Ireland. Don't let people create stuff there. And then the last thing that I want to talk about tonight, and there are many, many ways that you can secure your app. AWS has a series of white papers called the Well-Architected Framework that gives you lots of information about deployment and security. But the last thing that I want to touch on is to use secrets. And every cloud provider I know of has some way to store secrets. In AWS, it's called Secrets Manager. And I've been a big fan of the idea of configuring your app using environment variables. It's one of the 12 factors. If you're familiar with the 12-factor app, it was put together by people from Heroku of this is the best way to build your apps if you're going to be deploying into a cloud. And environment variables are great. You have one jar that you can deploy to dev, QA, prod, and what they talk to, such as a database, is configured just with environment variables. But as you saw earlier, environment variables can be exfiltrated. Environment variables are a little bit too public for what you should be doing in a production environment. So instead of having separate environment variables to specify all the components you need to log in to your database, instead, I strongly recommend you store that information in Secrets Manager. the standard is a JSON object, and then have one environment variable that gives a reference to it. And this is really nice because you can now have separate permissions on these secrets. You can say, for example, that your developers are not allowed to see the database secret in production, but they are allowed to see it in the development environment. But they aren't allowed to see the secret, but they are allowed to see the environment variable that points to that secret. So it's a really easy way to say, oh, someone messed up the configuration, and this app is pointing to the QA database instead of the prod database. So again, I highly recommend take that extra layer of indirection. So those, as I said, are just 4 things instead of giving you dozens of slides and dragging on till 8 o'clock tonight. Those are 4 things that I think should be the basis of any deployment. Something else that the cloud gives you is a lot of ways to look at your environment and pay attention to it. And that can let you figure out, A, if you've been attacked, and B, what happened if you were attacked. Because even with all these features, it's still possible to be attacked. Excuse me. So the first thing is CloudTrail events. And like I said, Amazon Web Services is a web service. And just like every web service, it has an access log. Parts of the access log are made available to you as a user, and it's called CloudTrail. It's a service. And here's an example CloudTrail event. And you can see when it happened, the event time. The event name is basically the action that was taken. Here it's get secret value, the region it happened in, and the source IP address. And so if you're only expecting applications inside your VPC to be retrieving secret values and you see a public IP address, you know that you've got a problem. It also gives you a number of other pieces of information that I cut out for space, but who or what did perform the action? In this case, it's a physical user, me. So I know that if I wasn't doing anything with Secrets Manager on March 12th at 10:30 a.m. Eastern Time, my credentials have been leaked. And then I can start going with CloudTrail and see what else was done with my credentials. And I have an entire 45-minute talk on CloudTrail. A lot of capability, some pieces that you wish were there but aren't. It's free to set up, at least for your first trail, other than the cost to store things in S3, which is really cheap. Highly recommended. Turn this on in your environment if you have AWS. If you're running a web app, you have a bunch of different ways to get access logs. Tomcat writes out its access log. Jetty writes out its access log. The load balancer can also write an access log. And you may think that what's the point of having 2 things writing access logs? But it's really nice to be able to compare them. If you were running a web framework that was vulnerable to Log4Shell, the access logs that are put out by your web framework aren't going to show the $JNDI LDAP whatever else, because the way that the logging framework works is it does that lookup and puts the lookup value, which is probably an empty string, into your log. So you compare the load balancer logs and say, all right, I see a $brace in here. I don't see that in my web app logs. Time to investigate. AWS also gives you flow logs, which are a very detailed record of all the network traffic inside your VPC. And for the most part, they're overwhelming. I'll be quite honest with you. It's showing I think at every minute, the total number of bytes and packets moving between every node in your system. But it can be really useful to diagnose traffic spikes. So for example, if you see that your database is under load, take a look and turn on flow logs and you can see who's talking to your database and how much data is moving. The other thing that flow logs can do is they feed into some additional managed services which give you a higher level view. So for AWS, they have a service called Guard Duty, which ingests its own copy of flow logs. You don't need to turn it on, as well as CloudTrail, DNS logs, and EKS is the Kubernetes, the managed Kubernetes service. And then it applies some heuristics to that and comes up with findings that say, this is anomalous. You should look into it. I can't remember the price of this, but it's not that high. Worth turning on if you have a production deployment in AWS. And there's also AWS Trusted Advisor, which goes out and looks at all of the accounts in your organization. And for things like you have a security group that has a world open port and tells you about it. And you can say, yep, I understand that, or no, I don't, and start to investigate. And there are a bunch of other services. The first two are ones that I've used. The next two, and there are a bunch of others I haven't used. So again, interest of time. So that is the detail, and I'm going to send Gene the PDF for this. But I do want to have a couple step back a little bit and have some closing thoughts before we get to final questions. And the first closing thought, you may recognize this. If you asked any European prior to about 1800 to describe a swan, he or she would describe a bird that looks a lot like this, except all white except for a little band around its eyes. To a European, that was what a swan was. They'd never seen anything differently. Then in the early 1800s, Europeans went to Western Australia and discovered there are swans that are all black. And the author Nicholas Taleb took this as a metaphor, wrote a book about it called The Black Swan, about events that happen, mostly sociopolitical events, that nothing in your experience prepares you for. And I think it's really easy to think of the Log4Shell vulnerability as a black swan event. People have been using logging frameworks for 20 plus years in Java. They're rock solid, probably millions of deployments, multiple millions of deployments, using them every single day. 20 years, and then suddenly out of the blue, you get this vulnerability. And I'd like to step back a little bit and say, it really wasn't a black swan event. We've had vulnerabilities in the past. A few years ago, we had a case where Apache Commons collections could be turned into remote code execution vulnerability. Just 2 weeks ago, there was a vulnerability in the Spring framework that could allow remote code execution. You might not be prepared to spend the money and time to harden your systems if there's nothing that gives you the feeling that there might be a problem. What I want to suggest is that just because there's nothing in your experience that could be an attack, you should still spend that time and money, because it could come out of the blue, and really it's likely to come out of the blue anytime now. If not an accidental vulnerability like Log4Shell, an intentional one, such as deleting your entire file system if you're in the wrong IP address. And that brings me to my last thought, which is Linus's Law, which I think may have actually been coined by Eric Raymond. And this is kind of one of the fundamental reasons to use open source software, is that because everyone can see it, they can very quickly identify bugs. The vulnerability was reported to the Apache maintainers, I think on the 3rd or 4th of December, and within days there was a new version of Log4j, and it came out before the actual announcement or disclosure of the vulnerability. You didn't have to wait for Patch Tuesday. Even if the maintainers were not doing it, you could go in and figure out what's going on with the code. So I think of this as an incredibly important reason to use open source. The other side of that, though, I'm going to call Keith's corollary, is that to know that a bug exists, it has to bite someone. Our deployments today are just amazingly complex. I was doing something with Hadoop a couple weeks ago, and if you pull in the Hadoop client jar, it pulls in over 100 other dependencies along with it. And it's quite simply impossible if you use a large framework such as Spring Framework or Hadoop or really any Apache framework. It's impossible to fully understand the entire code base. You are relying on other people using it, other people stumbling over problems and fixing them, uh, and the goodwill of the maintainers to fix problems, especially vulnerabilities, quickly once they're discovered. But because of the possibility of 0 days, I think that it's incredibly important not to simply rely on open source maintainers to do all of this, uh, and not simply to rely on having software that has worked with flawlessly for 20 years. I think you really do have to step back, look at your entire deployment environment, figure out how to harden the parts of your application, uh, if only for blast rate, controlling blast radius. But networking is pretty easy to accomplish. And look at your applications as if they're being attacked. And I personally, having worked both in self-managed environments and a lot in the cloud environments, I think the cloud gives you a lot of capabilities uh, to really harden your environments that you don't get in self-managed environments. So that's it. Came in at 50 minutes, and I'm going to turn it over to any questions at this point.
Again, thank you, Keith, for this presentation. Log4Shell has been on everyone's mind since December. It's a very interesting case, and thank you for discussing how cloud can be used, how AWS can be used to mitigate the problem or possible future issues.
All right. Well, thank you for inviting me to talk. I will see everyone, I guess, when the jug returns in person.